All right, hello everyone. My name is Timothy Lee Grant. Today we are going to be attempting for the third time to do this 463 island perimeter. I've been trying to get it over and over and over and over. We can even go to submissions. I this is an easy problem, by the way. Easy right here. And the only reason that it says accepted, like solved, is because I went to GPT and I was like, I can't figure out what my problem is. Where is my error? I looked at GPT and I still couldn't figure out what I was doing wrong. I then copy and pasted because I'm like, is it just like the problem has some kind of issue with it? Like maybe it's not able to. Maybe that's an impossible problem. Like there's some strange issue with Leetcode or something like that. So I copy and pasted it into here, press submit, and then it accepted it, and I was like, okay, but we can't give up. We can't give up. So today, I am going to be revisiting. Let's see this. Can I just copy to editor? Okay. So I believe this was my last submission, and now the I'm not going to leave because I've done this 3 days now. Like I've attempted this over and over. I'm not going to stop until we figure out this problem, why I keep failing at this problem. We're going to find my error. We're going to find what's up. It's the only way to learn. Only way to learn. And this is like, as I've been saying, like this problem is actually easy, not just in terms of like its classification, but in terms of it's legitimately it should be a basic level uh, problem. Why am I not able to figure this out? Okay, so can I? That's as small as I go. Okay. And did I float on top? Yes, I did. Cool. You are given. Okay, so I'm given this grid that is the map. And then I and J, column and rows. 1 equals land, 0 equals water. So this is going to be a land, that's going to be water. Great. Grid cells are connected horizontally and vertically. Okay, you can look up, down, left, right. Good. The grid is completely surrounded by water. Yep, so if you look off the bounds of the array, it's water. Okay, cool. The island doesn't have lakes, and there's only one connected landmass. Yeah, so anyways, the method that I was trying to do is I'm first going to go through this grid, and I'm going to check each cell. Once I find a single cell that does have land in it, I'm then going to go and perform a depth first search on this. And each time I visit the land, once I'm doing the depth first search, I'm going to visit the land, and then I'm going to look up, I'm going to look right, I'm going to look left, and I'm going to look down. Now, each time I look up, down, left, right, I need to make sure that, or if I see water above me, then I know that I can add 1 to the perimeter. If I see water to my right, I can add 1 to the perimeter. If I see land below me, I need to add that land if it's not visited to my stack to say, hey, I'm going to visit this soon. And then this one right here is I see water, so I add that. But when I submit this, it fails on the case where there's land, 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 land. I can showcase that here. So my answer is, so you see land, 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 land. That's a 4-dimensional array, all lands. My output is 10, and the expected answer is 8, which if you look at it, does line up with reality. 1, 2, 3, 4, 5, 6, 7, 8. So why is my code having this issue? I take the next element from the list, or from the stack. I then say, hey, I'm now visiting that current element. I am then looking in all 4 directions. And each time I look in that direction, I can and this is kind of redundant because I added this line here, but in the past I deleted this line and had that line there. So actually I can just re-delete that. So then I look in each direction, up, so if I'm looking up, then I know that I have, and it's outside the bounds of the array, which is less than 0. I know that it's water, so I can add 1 to perimeter. If I'm outside the bounds of the array here, so I'm looking right or left, then I can also add water. If I am outside the bounds of the array here, I can add water, or here I can add water. So then I just check, like, oh, okay, so I'm within this grid. Okay. So I can index the direction which I am looking at. And if it is water, then I can add perimeter. Else, I say, okay, so it's not outside the bounds of the array, and it is not water. Therefore, it has to be land. What type of land? It's either visited land or unvisited land. If the direction that I'm looking at has not been visited yet, I just want to append that to my visited. And then I want to keep doing that until I have nothing left in my stack. Then just return perimeter. So that's what I'm doing, and I cannot figure out why this is wrong. I cannot figure it out. So what is wrong with my implementation? Last time I went to ChatGPT or Copilot, and it gave me an answer, and I don't know if I was just like too upset or what, but I couldn't even figure out why its solution was correct and my solution was not correct. What? See, it has to think too. It's having difficulty with this problem too. Good. It's not just me. um, let me just. Okay. Okay, what's wrong with my implementation? Your implementation is very close to working correctly. Let's address a few key points to ensure it's functioning as intended. Early return for grid empty. You have correctly handled this case for grid empty. Okay, I'm looking for just what I did wrong. So good. You correctly, good. The perimeter seems correct, but there's a minor comment related issue. Um, but okay. So it is saying the commented out line of code, which is this one right here, but I initially had this uncommented and submitted it like 2,000 times. Like all of this, right? Like I initially had that uncommented, should be active. The reason is that we need to check if the neighboring cells has been visited before appending it to the stack to avoid redundant processing. But I do that in this line. Like this is the only time that I append to the stack is right here. And I am blocking with this uh, um, line right here. So that honestly does not really make sense. Right now, I'm just going to try to see if I can do this and if that will work. I don't think it will because, yeah, it doesn't work. Yeah. I don't think that's the problem. Ensure that we skip already when popping from the stack. Fortunately, I can't just directly copy and paste from here. I have to go like this. Let's see. That should be the right indentation for that. And get rid of this. There. Let's see if this works. Okay, so this. Okay, so somehow there is a difference between what I did here and what it did here. Come on. There's some difference, but I'm gonna go. Okay, so while stack, I then do this. Yes, that's this. Oops, that's the same. Now it here immediately blocks this. If I and j are invisited, it immediately just goes to the next one, whereas mine does not. But the question that I have is there ever a situation in which an element in the stack, in my stack here, would be in visited? And the reason that I say that is because I this is the only line of code right there that I ever touch stack. Well, okay, I touched it up here for the initial, like adding an element to stack, but once I do that, this is the only line of code that I ever touch stack. And it's blocked right here, not in visited. So it seems like it is impossible for a visited node to be in the stack. Therefore, it seems like this line of code is redundant, but its solution is working and my solution is not. Visited add, I have that. Then 1 0 negative 1 0 0 1 0 negative 1. Yep. DI DJ. And then they just create these right here, which are just like the direction in which you're looking. I explicitly like write it out, but it's the same thing. So anyways, they don't have this line of code here. They simply look to see if the direction that you're looking is less than 0 outside the bounds of the array, therefore it's water. If it's less than 0 in the column direction, yes. If it is greater than or equal to rows, if it's greater than or equal to columns. And then this one should be if it's water. If it is water, yeah. And then you add perimeter. Else, if where you're looking is not in visited, they have and is equal to 1. I'm trying to figure out, is that a redundant line of code as well? Because this should be all the cases that it is water. So if it is not water, it should be land. And land can either be visited or not visited. So why do I need to explicitly check it? I'm not sure. But their solution is working and my solution is not. So then you add it. Okay, I'm just going to try their solution. Like, so let's see, submit, this should be wrong, but it should be fail on this one. Okay, so we're back to where we started. Now, and grid of, actually I can just copy and paste that. this equals to 1. Let's submit this and see if that solves our problem. No, that did not solve our problem. They also added something here, which was that if ij in visited, continue, submit. Let's see if this line of code fixes it. Visited. Okay, so this line of code is the problem. Let me actually just take this out and see if this will work. This also works. Okay, so we found the issue. It is this line of code here, but I don't understand why. Great, we found the reason, but finding the reason without understanding the reason is not ideal. Like, that's not the point of this. Is to be able to understand what's going on, understand why something fails or does not fail, why you need something or do not need something. And as of right now, I still don't understand why I need that. So information that I have right now, first, is I know that this case fails. My case fails for land, 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 land. My case gives 10 when it should be 8. Put this line of code in, and I get the correct answer. Code seems to be that caused my solution to fail and your solution to pass, but I do not understand why this line is required. In specific, my code failed on the case one. My code gave the output 10, but the actual should be 8. Okay, the reason that I feel this line should not be required is because in the line of code that I append, elements or locations up, down, left, right that I am looking at, I only add that are not in could it be the case that when I'm looking up, I'm trying to think like I haven't, so if I'm at a specific location, I'm looking to my right and I add that element to the stack, but I have not added that element to visited yet. Is there any way that no, that wouldn't make sense. Because I'm not adding an element to the stack twice. And even if I did add an element to the stack twice, no, that doesn't make sense. I only add elements that are not in visited. Therefore, I feel that there will never be a case that can you show me, can you walk through of why, I'm just going to copy and paste that, fails. Okay. Cool. Let's walk through step by step why 1 1 1 1 fails is necessary. Okay, so 1 1 initially stack is empty, visited is empty, parameter is 0. So that's our starting case. That makes sense. Finding first cell, we should find the first element. So iterate over the grid to find the first land cell. 0 0 equals 1. Add that to the stack. So stack is 0 0, stack 0 0. Good. Life is in order. Okay, so I pop 0 0 from stack and add 0 0 to the visited set. Yes. Yep. That's how it goes. Check all 4 directions. So down is land, and we're going to add that to stack. So 0 1 is now in the stack. That is correct. That is in accordance with this. Like, I'm here. This is land. I look down. I see land. So add it to the stack. Cool. Up, outside the bounds of the array, increase the perimeter by 1. Good. Look to the right, and I also see land because it's all 4 land. So I add that to the stack. So now 0 1 is in the stack. Very good. Left, out of bounds, so increase the perimeter by 1. There we go. So now the stack contains the one below it and the one to the right. Visited is the first element, the top left. Okay. Iteration 2. So we take the one to the right. Okay. Add the right to visited. Okay. Check all 4 directions. Check all 4 directions. So Now, down is land. Hold on a second. I think I'm understanding. Maybe. Is it that right now the stack contains these two elements, and both of those elements are in the stack, but only this one is visited. And now I'm going to take this element, I'm going to remove it from the stack and put it in here, in visited, and I'm going to process this one. But this one is in the stack. It's in the stack, and it is not in visited. So when I'm processing this one, I'm going to look to my whatever this is, right? I'm going to look and I'm going to see this element and be like, oh, it's not in visited. I'm going to add it to my stack. Now I have this element twice in my stack. I think that's what is going on. And so then I process this element, and because I don't just pop out right here, I actually go and so I do have multiple elements in my visited stack. I see. So I do have multiple elements in my visited stack. So then I look at the element twice because I don't block it here. And I see, oh, I see water. I see water again. So I just add to perimeter. And it doesn't matter that I'm blocking, like I'm not adding more nodes, like more visited nodes here. I already have two elements in my stack that are the same element, and so I need to, okay. So this line of code is hitting, and it's increasing the parameter. Just trying to like understand this a little bit more. So what if I did something like this? If this is not invisited and the other ones, does this work? What? Oh, no. Sorry. If DI, so the direction in which I'm looking at, and DJ, if this is not invisited, does that work? So no, it does not work. So well, So I'm only adding an element if I'm only adding to perimeter if the direction in which I'm looking. Oh yeah, actually that does make sense because I'm going to be at a node twice. And I never add water into the I never add water into the visited set. That wouldn't make sense. I can look at water as many times as I want. The problem fundamentally is that this visited this visited landmass twice. And so I then go and okay, that makes sense. Great. Now, let's do this. Okay. Here we go. Description. What do I want to do? I want to perimeter equals 0. Okay, so now I want to have a stack. Stack equals, it's going to be a list, and I want visited, and that equals a set. Okay, so now, for I in range rows, for j in range calls, rows calls grid good. If not grid, return 0. Good. So now, if grid of ij equals 1, then I add that to my stack. Stack.append, and I want to store it in a tuple, so ij. Okay, then I want to break out of this, and so I break out of this for loop, this j for loop, but now I need to check, like, do I have anything in my stack? So if stack, then I just want to break out of this second for loop. So now I'm here. Cool. So now while my stack is still, there's still an element in my stack, I want to take that element out. So current equals, no, I just want ij, and that is going to be equal to the stack dot pop. Okay, so now I want to this is where I need to make sure that I'm not visiting a node that I've already been to. So if ij in visited continue. Okay, else I just want to add that to the stack or the visited. So let's see, visited dot add, and then I want to add ij. Cool. So now what do I want to do is I want to look in those 4 directions. So I think I called it dj equals, no, what was it, like 4 di dj in, and then like this, and then I had the 4 cardinal directions, so like 0, 1, 0, -1, negative 1, 0, and -1, 0. So iterate through all 4 of the cardinal directions, and now I want to determine if the direction that I'm looking. So I'm gonna go. They did in I equals my current location plus di. In j equaled j plus dj. Okay. Then I want to check, like, is it water? So first I need to make sure that I'm inside the bounds of the array. So if in I is less than 0, or in j is less than 0, or in I is greater than or equal to rows, or in j is greater than or equal to calls, or a grid of in I in j is equal to water. Then we can add 1 to perimeter. So perimeter plus equals 1. Otherwise, else elif stack ij. Good. Great. There we go. Okay. So, unfortunately, I know that I will need to revisit this problem in a few days. Probably give it like a week. I don't want to ever see this problem again, but I know that I have to because if I do it now, okay, great, I can solve it. 3 days into the future, I can probably still remember it. If it's a week, okay, let's do it one more time a week, and then that will like burn it into my memory, and then I should be able to be very quick at this. As I've been mentioning, like this is an extremely good problem because it is an iterative graph traversal of and the only difference between like depth first search and breadth first search should be this line right where is it right here. Like if I wanted breadth first search, I would just do that, right? So this is extremely helpful in teaching me the concepts of graph traversal iteratively using a grid. Um, and so I understand that it's extremely important. This is a really good problem, which is like something that I am grateful. On one hand, I'm grateful that I encountered this problem, but it was also like I've spent a lot of time on this problem. um, so yeah, I think I understand it now. I think I understand why I was making that mistake. I think I understand what was going on. But I will need to revisit it in the future. I need to make sure that I got it. I need to make sure that I can easily pull out a depth first search or a breadth first search iteratively and recursively, but in this case it's iteratively. And I need to be able to do that quickly and understand what's going on. So yeah, I will. I'm gonna. My plan right now is to move forward and continue doing Leecode questions on other Leecode questions. I'm gonna give it a few days, about a week, and then I'm gonna come back to this problem, try it again, and I'm even going to make it where when I first see it, I will not see the answer. So yes, I want to do that. There we go. So now next time I come to it, I will see just this blank screen right there. And then it's time to do the test. So anyways, thank you guys so much for watching this video. Um, and yeah, hopefully it wasn't too like annoying that I am trying the same problem over and over and over. This is my third video on this exact same problem. But I also think it's extremely important. Firstly, I think that the problem itself is extremely important because it teaches a fundamental skill of like these Leetcode questions and graph traversal, which is like how do you traverse a grid through either depth first search or breadth first search. So how do you iteratively do that? That's an extremely important skill. And number two, I also think it's really important like once you are unable to solve a question, okay, it doesn't it does help by doing a ton of problems, right? Like the more time you spend with it, the more you're going to learn. But it's much more effective to like do the problem and then try to understand why your solution didn't work. So that's why I spent so much time on this problem, even though trust me, I really wanted to just go to a different problem. I really wanted to visit another problem, but that is not the correct way to do things. So anyways, thank you guys for watching this video. My name is Timothy Lee Grant, and I will see you tomorrow with another Leetcode video. I think actually I'm going to be filming a different kind of video. I need to do little bit more projects. So I'm going to do a video where I'm just trying to learn Java because I haven't really touched Java ever. So trying to understand Java, learn Java. I heard it was extremely important. So I am going to be doing that. So, anyways, that's going to be a little bit more of kind of like a chill video, just hanging out, trying to, make some progress in the language, learn the fundamentals, stuff like that. Anyways, so I'm going to be making that today. And then tomorrow I'll do a Leecode video. So if you'd like, please subscribe to this channel. That would be awesome. I would definitely appreciate that. And I hope you guys have a wonderful day.